Hello and welcome to YMT217 Programming Languages. Today we are going to discuss the first part of Chapter 3 describing syntax and semantics. And we will be just covering a simple introduction about the topic and the general problem of describing syntax. So what we are going to discuss is just an introductory part plus some definitions and prerequisites to the whole topic. Alright, before we begin, before we discuss the general problem of the description of a language or language description, we need to understand what this language description is and what is it meant for. Why do we even need to care about it? Why do we need to discuss this topic? Now, imagine you as a programmer of a language, you don't know how a statement is composed, or why it is composed this way. If you don't know these elementary parts, how can you code? Or let's say, for a certain reason, you need to know which one comes first, which token or which part of the statement that you are typing in the programming language, why we type this one before the other one. For example, if let's say you're creating a for loop, why do we put for at the beginning before the parentheses in Java, let's say, or any other programming language, C or C++ or any other? So why do not we put for example, at the end, the very end? And for that reason, there is some rule, and we need to learn it at the beginning. So we need to understand the description of the language, or the proper description, and now we will categorize this description in details after a while. But before that, so I give the example of users, all right, or programmers. Why? Because they are the most common, or any programming language which is available is commonly used by programmers, unless it is designed for a specific reason, for maybe one team by themselves. So it's not widespread. But for widespread programming languages, it's commonly used by programmers or users. But in reality, we don't only have users. How about those who design the language? Those who design the language, they must understand its own description or definition in details, in a very precise way as well. Otherwise, they wouldn't be able to set its own design. The same goes to those who implement it, the implementers. So those who implement a language must carefully understand its own description, or precisely understand it, have the full idea in details about it, so that they can implement it. Implement it here means what? Means create or transforming the design of the language itself to a programmable software that we can use and code with in this case. Okay, so again, we have those who are involved, mainly the users, the implementers, designers, or what we refer to in this case. They could be also evaluators. Okay, they could be evaluators, not just basic users. Evaluators, I can describe them in a very basic sentence as a potential user, or users with some skills. Like they could be part of an organization. I'll explain it in a short while. So the description of the language is extremely important for those who are involved with it, need to use it or design it or implement it. Okay. So what is the description itself of a programming language? Okay, this is the formal definition of a programming language. A formal definition of a programming language itself may be extremely difficult or somehow simpler based on the language itself. Yet, the level of difficulty will vary based on who we are speaking about. Are we speaking about those who implement the language, or those who are designing the language, or those who are using it? Well, for users, usually the formal definition is not that much difficult. But while for designers, it may be much harder. For evaluators or maybe implementers, it may be much harder than what we expect or what we think. All right. So I said I would explain about the the potential users, usually a programming language before it is given to public or provided as a programming software, it is tested, or it must be tested by some potential user, and these users work as evaluators. Potential users here, we speak about some people with let's say adequate set of skills to evaluate whether the programming language is up to its own specifications or not. Okay, like we can say the initial users, but with really good skills to judge. All right, and that's why they require a high level of precise description of the language. The same goes to those who implement the language, the implementers. They must understand the precise description of the expressions, the statements, or the composition, in other words, the structure of the language itself. So if we want as user to create a program, we need to know these compositions, but we don't have to understand the formal definition of each and every one. Actually, the optimal way is to do that. Why? Because it will allow you to understand properly and fully how the language is operating. Yet, if you don't get the whole idea about the formal definition of all these things, you still can code with a programming language, but you can't implement it. If you do so, most likely you will implement something else in between. So you have to understand fully what and how the expressions are. Expressions are meant to be, statements are meant to be, and the programming or the program units are supposed to be provided so that you can implement them in a proper way, or you can implement the whole programming language in a proper way. And this, for the implementers, their job, their task is somehow directly affected by the completeness and the precision of the language description itself. Why? If we give a wrong description to an implementer, we expect a wrong implementation or an erroneous implementation. So the description here matters. Or maybe if we give not a wrong, an incomplete description. If you remember from the principles of software engineering, we studied it last year, the idea of software development, like when we give the requirements of a software and how extremely important it is for achieving or creating the software in a proper way. This goes the same direction, into the same direction, or goes in the same direction. Means what? We speak about an implementer or some implementers that require a very precise and complete description in order for them to create the programming language. Okay. And for users also, they need the description. Why? To understand what they are programming with, to read the manuals, to understand how they can compose a sentence, and based on what the sentence will be evaluated. Yet, their job is not exactly affected by the description of the language. It's rather more affected by how difficult and easy the language is, plus how effective it is in programming. All right, so when we speak about the definition or the formal definition of programming languages, we are referring to somehow a relevant concept to the natural languages we speak with, like English, for example, the language that I'm explaining right now the topic with. We speak about two main concepts. The first one, what we call, or what we refer to by syntax, the rules of the language, is very similar to the grammar in natural language, how we compose statements or sentences in a programming language. So that's the set of rules applied to compose the correct or syntactically accepted sentences or statements, and the semantic, the meaning of these composed sentences. Semantics here in this case is one word. It's not exactly plural. You just deal with it as a word the way it is. So if you say semantics is, do not be surprised. It's just a collective word in this case, okay? So again, the syntax is actually the formal structure. The formal structure of a statement could be also composition of, expression, could be also programming unit. In other words, it's the structure, the proper structure, the formal structure of a programming language. So this is the first important concept we have in defining programming language, and it is very relevant to the grammar in natural language. The way we are supposed to compose a correct or a valid structure. Semantics, we set the meaning of the expressions or statements or programming unit. The meaning of the syntax itself, okay? In other words, so syntax and semantics, they provide the language definition. And the language definition, as we just explained earlier, is important for those who implement it, those who program with it, and also maybe evaluators or whoever is involved with a programming language. All right, let me give you a simple example about the syntax and semantics from a language that you guys are familiar with. You studied in introduction, sorry, in algorithms and programming. Sorry, I forgot the course for a second, sorry. So this is the idea. What we have like a statement related to looping. It's a looping statement, and in that case we can use for loop or while loop, but let's just stick to while loop for a minute and see how it can be described in terms of syntax and semantics. In terms of syntax, a while loop itself can be written this way. While, this is a keyword, and then we have these parentheses and some Boolean expression written in a formal way, and then we have a scope. So we have a scope here for execution. It could be multiple statements or block of statements. It could be also just one statement. It depends on your application. So this is the syntax. This is how you're supposed to write it, not while, let's say, at the end, or not the expression, the Boolean expression before while or after the statement. So this is the proper way of formulation. It's like the grammar, which comes first based on the own structure. That what comes first is a keyword for looping, then we have the parentheses, we have the Boolean expression, then we have a scope for statements. This is the proper syntax. About the semantics, usually the semantics is more elaborated. Why? Because we speak about the meaning, so we have the meaning of different parts, and I'll explain about the names of these in a while. So we have, initially we have what? We have the looping instruction, and then we have a control instruction, Boolean expression, and this Boolean expression will be evaluated first. If it is true, these statements will be executed. And then, once they are done, we have again a transfer to the control here. This is the controlling statement, and it will be re-evaluated. Usually we have an alteration somehow of this Boolean expression, but if it is not, it doesn't matter. Why? Because the evaluation will be transferred to it, and we will see, we will re-evaluate if it is true or not. If it is true, the same process will be repeated. Otherwise, the whole loop expression or a statement in this case will be skipped, and the next construct will be evaluated. This is the semantic, and you see for just the simple loop we have the semantics written this way. Okay. A programming language itself, if we speak about its own description in terms of the syntax. Now, what we need, so syntax, the structure. What are the compositions or what are the structures of a programming language? Let's go from the smallest, or before we go from the smallest, let's speak what the language is, or what could be even in natural language, actually a set of sentences. So we speak about sentences. Usually in a programming language we refer to them by statements, and you guys are familiar with statements. So what's a statement? A statement is a set of characters. Here, what we refer to by character actually string of characters. That means we have different characters over the possible alphabet of this of the programming language itself. The alphabet here is what? The valid or the possible strings or characters that we can have from the programming language itself. Okay. So now we have sentence. We have a programming language, a set of sentences. How about the sentence itself? As we said, set of characters. Well, if we compose these characters to create one part, what do we call this part? We don't call it a string, we call it a lexeme. This is the lowest level of the syntactic unit of a programming language. Usually while describing a programming language, we don't describe the lexeme. Why? Because if we need to describe the lexeme, we will have really a complicated description of a programming language. Rather, we describe its own like sentence composition. That's much easier. However, we have the lexeme as the smallest unit, the lowest level of the syntactic composition of a language. Now think about variables, think about identifiers, think about operators, keywords. These are all lexemes. And lexemes in this case, we don't exactly give their definition in details while describing a language. If you want to read their definition on your own, that's possible, but you don't have to give it as a description so that you fully understand the syntactic analysis of the language. Really not. That will complicate the whole definition of a language. Again, in the basic sense, lexeme is the lowest level of syntactic unit of a programming language. And usually we don't give its own full description, or it's not required. Actually, its full description is available, but it's not required for describing a language. It's enough to know what it is, and that's adequate. Why? The reason, if we give its own full description or definition, it will complicate the language itself, and it's really not needed for syntactic analysis later on. Okay, so this is what we refer to by different types of lexemes. I said we have different categories, and each category itself is referred to by a token. So in lexemes, or the divisions of lexemes are referred to by tokens, and each category is composing a token, a separate token. Okay, so this token is, it could be, as I said earlier, an operator, it could be an identifier, or any relevant part of the lowest level of syntactic unit in the language. All right, let's take an example. This is a Java statement. It could be also C or C++. It applies the same concept to these. So we have here a named variable. We can refer to it by an identifier here. Okay. So this is a token. It's a token. Its category is identifier in this case. We have also another token here, or lexeme, the equal sign. Okay. Also, we have here an integer literal. This is a literal. So it's also another token. This is its own definition. We have an operator, the multiplication operator. Again, we have another identifier. So we have these two from the same category of lexemes, but they are tokens again. And then we have the plus also sign. That's also a lexeme or a token. Finally, we have also an integer literal. Again, these two from the same category, integer. We have the semicolon. That's a symbol also for termination symbol. Semicolon is a token by itself, and it's also lexeme. So what I want you to understand that these are lexemes or tokens. Why do we explain about them? Because we will need them for syntax analysis next chapter. Okay. So we speak about the formal definition of a programming language. We have different methods of formal definition of programming language. So the first to be explained is, now we have a language, a programming language. We can assume that this programming language is composed of set of characters or alphabet of characters. We can refer to it by sigma, and the language itself is L. In order for us to define L, the whole language statements that composed from the possible alphabet characters sigma, what we need to do, we need to have a way for recognition or a way of generation. Not necessarily only recognition. We can have, I will explain about it in the next slide, but we can have recognition of an already available statement, or we can generate a valid statement or a valid part or structure of the language. So in that case, we have two types of definition. Here we have, or methods for definition. We have the recognizer. We can create or compose a statement, and then we need the mechanism R to recognize whether this composition or structure is valid or not from the language given by sigma, or set of characters given by sigma. A recognizer will do that. Imagine it's a device that you input to it a composition of the language, let's say a statement, and see if it is valid or invalid. Usually we use recognizers for syntax analysis. We will explain about those in the next chapter, in chapter 4, and it's an essential part of any compiler. Okay, so that will be explained in the next chapter. However, it's an essential part. That's very important. You provide a language construct or a statement, and then the recognizer will see if it is valid or invalid. Okay, we will also study this kind of thing in discrete mathematics. Soon enough we will study it. Okay. The other method is the generation. Now for the recognition, we may have any type of an input, and this device, or you can say a recognition device, will determine if it is invalid or not, if it belongs to the language or not. Okay. The generator, however, is not exactly like that. You imagine it's a device that has like on-off button, and you can press this button to produce a valid sentence from the beginning. So it's a device that generates for you sentences from the language, valid sentences from the language. Okay. So this is the idea. We can use the generator here in this case for comparison purpose, to see if any statement that we compose ourselves, is valid or invalid in terms of syntax. So if it is syntactically correct or incorrect. This is extremely useful in this case. In reality, we have both of them. We use both of them in programming languages, and we will see this in the next part when we start having the formal definitions in practically. Until then, have a good time. Goodbye.